Hello again, everybody, and thank you for clicking in. We appreciate it. I am Christian Garman with the University of West Florida's Innovation Institute, and once again with me, Dr. Bill Huth, Distinguished University Professor in the discipline of economics. Dr. Huth, this is our final segment, and this is one I know you're going to like talking about because it's near and dear to your heart, scientific diving. Now, you told me, I can't remember if it was during the segment or not, that I need to learn to dive, and I would agree with that, but what we're talking about here is not the kind of thing I'd be learning how to do. What is scientific diving?
Well, scientific diving is actually being able to go underwater, and then do experiments. So in other words, you develop a research hypothesis that you want to test, and then you gather data underwater to test it. So other scientific diving that takes place is, of course, archaeological, biological, etc. I'm very much interested in water quality, so I use diving to actually measure water chemistry and then statistically look at water chemistry change over time. Right now I'm very much interested in saltwater intrusion, and that interaction between freshwater and saltwater. Given climate change and sea level rise, the first place that happens is underneath, to the ground where saltwater and freshwater mix. And we have a lot of those locations here in Florida.
The kind of stuff you're talking about, the measurements you're talking about taking, this doesn't seem like the sort of thing that anybody that knows how to dive could do. I mean, is there a way for someone watching who says, hey, I would love to be part of that? Is there a way to become that? Are there classes? How do you?
Sure, well, UWF has a scientific diving program.
Okay.
Just as a basic open water diver, maybe taking advanced open water diving, then you can take the scientific diving course at UWF and become a scientific diver. But UWF is sort of at the beginning stages of that programmatic development. Most of what they do is not technical diving. And what I'm interested in right now, and I'm working with other people on this, is developing a technical scientific diving program. We define technical diving as basically diving deeper than 130 feet and using gases other than just air to breathe.
Okay, as an outsider, what does that mean, using?
Well, we're breathing air right now, and the air we're breathing, is basically 21% oxygen and 78% nitrogen. And so what you would like to do, nitrogen underwater is an inert gas and it's absorbed into your tissues. And so you would like to have less of it in what you breathe the deeper that you go. And so we replace that with helium. And that changes what it is you're breathing, and you have to manage those gases very carefully, when you're under pressure.
And I would imagine your voice is all of a sudden going to be very funny sounding.
With helium, yes it is. It's the Donald Duck syndrome.
I could not avoid the joke. I apologize. You have some equipment for us here. These are the sort of things, I guess, that are obviously part of scientific diving. Are these things you take with you, or this will be out there? How does it work? Show me what we got.
Well, this right here, this is a YSI 6920 V2 multi-probe data sonde. The probes are all in this area. It has a dissolved oxygen probe, it has a conductivity probe, it has a pH probe, has a depth probe, and temperature. So all of those things are being measured by this device when you take it into the water. So right now it's actually set up to be deployed. You basically program it. There's a computer inside.
Yeah.
You program it to take a sample every X period of time. For example, I usually sample about every 15 minutes, and then leave it in the water for several weeks to a month. So I've had this in the water in a local spring over near Gainesville during a tropical storm, Francis.
Oh, okay.
And so we were able to watch the fresh water, to flow into the underground cave system, in a real-time context with this.
When you saw the storm coming, do you guys
rush out?
And say,
Indeed we do, because it's an event. I really hate that I just missed, the storm that basically came up the Apalachicola, area, because there were some, because that generates the high point for storm surge. And so this instrument actually gets placed and left in the cave, and then, or wherever you're basically monitoring water quality, and then you go back to get it, you pull it out, to download the data to a computer, and reset it, and then take it back in the water. This, on the other hand, this is basically a hobo data logger. Now, this doesn't have as many variables that it's measuring. It does basically conductivity, and that's saltwater, it's a content. So it does the saltwater freshwater mix. And so this, you can basically deploy it in the water and then leave it there. And when you go to collect data, you bring a shuttle with you. And this shuttle just basically connects, so you basically connect the two underwater, and the data is then transferred to the shuttle, and you leave this in the water and bring this out and then hook it up to your computer and download the data. So this will stay in the water for several years. It's a recording information for you.
How much of this is out there in the Gulf? I mean, how many people are doing what you're doing? Are there thousands of these in the Gulf of Mexico?
No, these aren't in the Gulf of Mexico. We're putting these where the Floridan aquifer, which is the freshwater supply of 90% of Florida's drinking water, is where that interfaces with the Gulf of Mexico.
Got it. So where it's changed. I got you.
South of Crawfordville, over south of Tallahassee, is basically a cave system called Harvey's. Inside Harvey's is this geological feature called the Aphasia Pit. The Aphasia Pit basically starts at about 50 feet deep and goes 300 feet deep. So it's a huge pit, it's underneath the ground. But as you descend in that pit, you hit a hadelcline. That's where saltwater and freshwater are mixing.
Got it.
There's a real temperature change there as well, because Florida groundwater tends to be the average temperature, of the air over the course of a year. So at Mariana, it's about 68 degrees all the time. So as you decline and hit warmer water, you're hitting, some sort of flow from the Gulf of Mexico, and we're detecting that, with the salt water. So we're putting these data loggers in that pit so that we can measure how the tidal saltwater change is happening with the aquifer over there.
Scientific data is getting a whole lot of information, and you can do it at the University of West Florida. As a matter of fact, I appreciate you telling us about that. Well, Bill, I have so enjoyed our conversations. Thank you so much for coming in and talking to us, and just a lot of great information. Congratulations on everything you guys are doing.
Okay, thanks. We're having fun.
Dr. Bill Huth, I'm Christian Garman. Thank you for watching.